how we solve a very difficult project to synchronize the on-grid system with diesel generator. On-grid system with diesel. I'll introduce the single line diagram of this project. So here is a grid, okay? Normally from the grid, we have the ATS. ATS is a switch to choose the different source of the power. Here is a diesel generator, okay? When the grid is on, the ATS will switch here. So the grid can work normally, but when the grid is off, the ATS will switch to the diesel generator. And here is our load, L1, L2, L3, the different load. This already form a stable electricity supply system because when the grid is on, the ATS switch to here and the electricity goes this way. While the electricity, the grid is off, the diesel generator switch to this way and the currency goes to this way. But how we can form an on-grid system and synchronize the diesel generator with the on-grid system? You can see this is our solar panel, okay? And we are using Xenon 350 kilowatt inverter, 350 kilowatt. In total, it's 4.2 megawatt. They have different solar panels and different inverters to make the solar power plant areas, okay? And from this comes to DC, right? From solar panel to inverter. And output is AC. But in the big inverter, normally the output of the AC is not 400, this 800 VAC. Output, okay? And it's a long distance from the solar power plant to the load, to the factory. So we need to increase the voltage to reduce the resistance and the currency loss, and also correspondingly reduce the cable thickness to reduce the cost. So we will use a transformer, we call it a transformer, okay? From 800 VAC up to 11 kVAC to increase the voltage and transmit the currency to the load. And at the load point, we have a 400. This is another transformer. From 11 kVAC, we're gonna transform to 400 VAC. And here is the injection point. With this 400 VAC, all the equipments of the factories can work normally, like this. But there's one problem, for the on-grid system. Why we call it on-grid? Because all the system following the frequency of the grid, right? In some province, in some countries, it's 50 hertz. And in some, like Philippines, it's 60 hertz. The hertz means the curve's frequency. So all the on-grid system following the grid's frequency to synchronize the currency and voltage together. Otherwise, it will be counteract to each other. There will be conflict. While the grid is off, how we can maximize the solar power plant while using the diesel generator? That's the most difficult issue we have to solve. How we solve it? We are using a PLC, okay? The name is called COMAP. This is a European company, COMAP. PLC is you can treat it as a controller. It's like an energy management system to control the whole logic, to get the sensor, to sense the diesel generator working status, to control the diesel generator, to sense the grid status, to sense the load status, okay? It's like a brain. There will be a COMAP. So when the grid is off, the ATS will switch to the diesel generator and start the diesel generator, right? Then the COMAP will connect to the inverter and the diesel generator to maximize the output of the inverter of the PV part and correspondingly check the load. For example, now the load is 5 megawatt, okay? And the solar panel is generating 4 megawatt power. So the COMAP will tell the diesel generator to start generating 1 megawatt for diesel generator, for solar, for the load. So this is the current setup of our project in Middle East. We just synchronize the solar PV with the diesel generator for the load supply, okay? This is the current condition. And now we have another question because the solar currently is generating more extra energies to the grid. Well, our load cannot consume all the energies. So we need to use the BESS to take the energy from the solar while there's extra power and discharge it when there is not enough extra power, not enough power from the PV. So we will build a system like this. ATS, diesel generator, the load, solar panel, inverter. Here is a 400V point, okay? So we will use our BESS. This is the DC part. Together with the PCS, BESS will have 1500 VDC. And the input to the PCS will generate 690 VAC. and use a transformer to transform 400 VAC joint point. And overall the system, we will use a COMAT. Control the diesel generator, control the inverter, and meanwhile control the PCS. In this way, we can form a diesel generator, grid, solar panel, BESS together to form the grid power supply system. And here for the load, it will get a continuous 24 hours, 7 days supply with a maximum utilization of the solar power. So this is a single line diagram of the current setup.